Hello everyone, this is Mr. Gerzon and welcome to our lesson on work and power. Our objective for today is to define and calculate the work done on an object. We are going to use the formula work is equal to force times distance, or W is equal to F times D, which means force and distance. In the work presented, you are given 4 examples wherein you are asked to convert the energy from one form to another. So let's try to answer the following. The first one is a mower. What energy does the mower have and what is it converted to? The answer is the mower has a battery, so it therefore has a chemical energy in the battery, and since it moves, then it is converted into mechanical energy. The second one is a toy which is powered by a rotating key. The rotating key converts elastic energy into mechanical energy. Elastic because the rotating key contains a spring. Next one, the firewood in a fireplace contains chemical energy and is converted into thermal or radiant energy. The last one is a yo-yo. The yo-yo converts gravitational energy, which pulls the yo-yo down, and is converted into mechanical energy, and since it's moving back and forth, therefore conversion energy is from gravitational energy to mechanical energy and back to gravitational energy, and so on and so forth. Now we're going to discuss about our lesson now. What is work? Work is the force exerted over a distance. It means to say that when you exert a force on an object and the object moves, then there is work done. If you apply force on an object and it doesn't move, then there is no work done. Work is measured in the form of joules, which is named after James Joule, who discovered the relationship between work, force, and distance. In this example, you would notice that a guy is pushing a cart. Now, there is work done here because there is a force exerted by the guy on the cart, causing the cart to move in this direction. So there is distance covered. Therefore, it has work. The second example that you will have shows a guy standing on the cart. The cart is not moving and the guy is not exerting any force. Therefore, there is no work done. The third example that you will have shows a guy pushing a vending machine. The vending machine is being pushed by the guy. Therefore, the guy exerts a force in this direction. However, the vending machine doesn't move, and so therefore it did not cover any distance. Thus, we could say that there is no work done. Work, therefore, has a formula: force times distance, which means to say that when you exert a force on an object and the object moves to a certain distance, therefore it has work, or work is present. To abbreviate the formula above, we could say work is equal to F, force, and D, which is distance. Remember, force is in newtons, while distance is measured in meters. Therefore, work is also equal to Newton, which is force, and distance, which is in terms of meters. I write it here, or simply joules, Newton meters. Example problems. I will now give you 5 minutes to solve on this problem. Pause the video and try to solve this problem. Now we are going to solve for this example on work. The first thing that we are going to do is again use the GAFSA method, which is the given, which stands for G, A for ask, F for formula, and S for our solution, and A for our answer. So we're going to place the answer at the bottom. Now, the first example that we have here states how much work is done if a bike is pushed 332.3 meters with a force of 14.7 newtons. So this is our given. The given are the numbers and their values which can be found in the problem. So the first value there is newtons. Newtons, we know that it is the force of an object, so we write here F, which is equal to 14.7 newtons. The second value that we can see in the problem, or the second number that we can see in the problem, is 32.3 meters. Now, there are only two factors in work, which is force and distance. Since we have force already, then we would know that this one is distance. What is being asked? How much work is done? So we write here work. What is the formula for work? Again, work is equal to force times distance. To solve that, here is a situation below, or the equation below. Work is equal to force times distance. Therefore, 14.7, which is our force, times 32.3 meters, you multiply it and you will get 475 joules. And that's what we are going to write here. Okay, our answer would be 475. I'm sorry, it's 475 joules. And we are going to encircle that. So now I will give you several problems to solve for work. Next problem. Pause the video, read the problem, and answer it. Now that you're done, let us try to get the correct answer of this problem, which is force times distance is equal to 7.25 newtons, which is our force, times 19.5 meters. We get 141 joules. Let us now proceed to power. Power is the amount of energy that is used over time. It is the amount of energy that is used per second. Power is measured in watts. Now, it is named after the inventor James Watt. Power uses the work done of an object as it through time, or simply say power is equal to work divided by time. Remember, work is in joules, time is in seconds. Therefore, watt, which is the unit of power, or W, is equal to joules per second. And that is watt. Our first problem goes like this. What is the power for a machine that uses 425 joules of energy every 60 seconds? We identify our given, we identify our ask, and we try to solve the problem. Our given is 425 joules. Now again, what are the given? Givens are the numbers that you can see in the problem. The first one is 425 joules, and the second number that you can see is 60 seconds. 425 joules is our work, and 60 seconds is our time. Okay, what is being asked in the problem? The problem asks for the power. What is the formula for power? Again, power is equal to work divided by the time it took for it to make or to have work. So to solve this problem, we say power is equal to work divided by time. Our work is 425 joules. Our time is 60 seconds. We divide them. We get 7.08 watts, which is our power.